How could a great empire build huge cities and roads faster than modern construction companies with their powerful equipment? Roman engineers created a unique system that was ahead of its time by many millennia. And allowed them to literally reshape the landscape of entire continents. Today we are used to years of negotiations, endless estimates, and long construction periods. But in ancient times, the construction of colossal structures took weeks and months. The Romans did not just build walls, they implemented standards that ensured the incredible speed and durability of each structure. Their secret lay not only in the materials, but also in the iron logic of managing huge masses of people. Watch the video to the end, and you will learn how ancient builders managed to lay perfectly straight roads through impassable swamps and mountains without a single computer. To begin with, I will reveal the most closely guarded secret that has puzzled scientists from around the world for centuries. You've probably heard that Roman buildings have stood for thousands of years, while our modern concrete starts to crack after just a few decades. The uniqueness of their method lay in the use of special volcanic ash from the town of Pozzuoli, which, when mixed with lime, created an incredibly strong chemical bond. This material did not simply harden, but continued to gain strength over many centuries, especially when in contact with aggressive seawater. The Romans did not just build quickly, they created structures that became stronger over time and became part of the very geological structure of the earth. Each construction project began with a detailed analysis of all the materials available on site, which almost completely eliminated the need for lengthy and expensive logistics. Engineers did not wait for deliveries of the necessary stone from afar, but used what was literally under their feet, skillfully adapting the recipe to the local climate and soil characteristics. This complete autonomy allowed large-scale work to begin as soon as possible after a strategic decision was made. Huge volumes of concrete were poured into pre-prepared wooden forms at such a speed that entire walls of amphitheaters grew before the eyes of astonished residents. It was a real technological revolution in architecture, allowing a permanent shift from slow manual stone cutting to rapid casting of standard forms. The main advantage was that concrete allowed the use of a huge amount of unskilled labor to perform the bulk of the work. Experienced craftsmen only set the general direction and strictly monitored quality, while thousands of people ensured a continuous flow of fresh material to the site. This organization of labor was very similar to a modern conveyor belt, where each participant knew their specific and understandable task. The speed of foundation construction was so high that Rome's enemies often simply did not believe the reports of their experienced scouts. They considered it absolutely impossible for a powerful stone fortress to appear where yesterday there had been nothing but a clear field or dense forest. Roman concrete allowed architects to create huge arches and domes without using bulky supporting columns inside the building itself. This saved a lot of precious time and materials that would normally have been spent on the construction of complex internal structures. The buildings turned out to be surprisingly spacious and functional, which was critically important for the rapidly growing cities of the vast empire. Even during strong earthquakes, such structures demonstrated remarkable stability thanks to their monolithic nature and the special composition of the mortar. The secret to their durability was both simple and ingenious, making any construction project as efficient and fast as possible. The empire's engineers developed mobile installations for mixing concrete directly at the pouring site. This allowed the mortar to be supplied continuously, eliminating the formation of joints and weak spots in the walls. Construction became a coordinated flow, where materials did not lie idle for a minute. The use of concrete also reduced the need for highly paid stone carvers. Most of the building could be assembled by ordinary legionnaires or workers under the supervision of a single architect. This made Roman construction the cheapest and fastest in history. Do you think modern builders should return to ancient recipes for the sake of the durability of our homes? We are very interested in hearing your point of view, so please write about it in the comments below the video. Your opinion helps us develop, so be sure to subscribe to the channel so you don't miss new investigations into the secrets of ancient technologies. Every message and subscription is important to us. Want to know the main secret of why Roman roads still serve as the foundation for many European highways? The Romans built their famous roads at a speed that seems incredible even with modern excavators and powerful rollers. The secret lay in strict military discipline and complete standardization of each stage of work over many thousands of kilometers. The road was not simply paved with stone, it was a deep, multi-layered cake capable of withstanding the movement of entire armies. Each layer had its own specific function, from the bottom drainage to the top coating, which prevented any erosion of the road. Engineers used a special tool called a thunderbolt to lay perfectly straight lines for tens of miles ahead. A straight path was not just an architectural whim, but a way to minimize travel time and simplify the complex construction process. If they encountered a swamp along the way, the builders drove thousands of oak piles into the ground, creating an incredibly strong foundation. They never looked for easy detours, preferring to overcome any obstacles directly using their engineering prowess. This allowed troops to move throughout the empire with unprecedented speed for that time. Construction was carried out simultaneously on several sites, which were then connected into a single network with remarkable precision. Groups of legionnaires worked like a well-oiled machine, with each stage scheduled down to the hour and minute. While some workers removed the soil, others filled the bottom layer with large stones, and still others prepared the lime mortar. This parallelism of all processes made it possible to build miles of roads in a matter of days, even under the most difficult conditions. As a result, the entire vast empire was connected by a network that knew no barriers in the form of weather or season. The roads were built to last for centuries, and many of them retained their profile even after the fall of the empire and centuries of oblivion. The Romans understood that mobility was the only key to power and spared no resources for the quality of the roads. Engineering here reached the peak of practicality, reliability, and incredible speed of execution. Each paving slab was fitted so tightly that often even a thin knife could not be inserted between them. This highest standard of quality was strictly adhered to throughout the entire territory, from foggy Britain to hot Africa. The materials for the layers of the road were selected taking into account the local geology, but the general scheme remained unchanged. First came a layer of sand, then large stones on mortar, followed by fine gravel, and finally massive stone slabs. This multi-layered structure distributed the load from the wheels of carts and the feet of thousands of soldiers. The road effectively became an elastic ribbon that did not sag under weight. The Romans created the world's first road construction standard, which remained unchanged for centuries. It was this uniformity that allowed them to build so quickly. Roadworks were often carried out by the legions themselves when they were not engaged in active combat. This solved the problem of keeping soldiers busy and provided the army with the best communication routes. Commanders competed with each other in the speed and quality of the sections laid by their units. Incentives for early completion of work motivated personnel to work to their full potential. The army was a self-sufficient mechanism that built its own paths for attack. Every step a soldier took on a new road was the result of his own labor. The paving technology was perfected to the point of automatism. Stones of a certain shape were laid according to a template. Workers used special hammers and chisels to quickly fit the edges right on the spot. The gaps were filled with fine gravel and poured with liquid mortar to create a monolithic surface. Once dry, such a road could withstand the passage of an entire caravan of elephants. The speed with which empty spaces were transformed into highways amazed the local tribes. The Roman road was a symbol of inevitable and rapid progress. Do you think that straight roads are always better than winding ones, considering the modern landscape and ecology? What I am about to show you is forbidden to discuss in some history textbooks because of its provocative nature. You've probably never heard of this unique secret, because the Romans built cities literally in the middle of nowhere in just a few hours. Every time a legion stopped for the night on a march, it erected a full-fledged fortress with a deep moat, a high rampart, and a clear street layout. It was not just a temporary resting place, but a fully fledged, fortified structure capable of withstanding an attack by any enemy with superior forces. Each legionnaire had his own strict role. Some dug the ground, others erected a palisade, and still others pitched tents. It is amazing that the whole process took only a few hours before sunset. The layout of any camp was always standard, allowing each soldier to find his place even in complete darkness. This completely eliminated the chaos and confusion that often destroyed other armies of antiquity during sudden night attacks. The headquarters and tents of senior officers were always located in the very center, and straight streets led to clearly marked gates. Such strict systematicity made it possible not to waste time on designing and thinking through plans on the spot. The Roman army was essentially a huge construction crew that was simply sometimes distracted by war. The scale of such daily work is simply impressive, as thousands of cubic meters of dense soil were removed from the ground every day. Soldiers carried special tools with them, shovels, pickaxes, and woven baskets for carrying soil, which were an essential part of their equipment. The considerable weight of this equipment was justified, as it ensured overall safety and speed of construction. Each legionnaire was first and foremost a builder, and only then a warrior, which made him practically invincible in long campaigns. The enemies of the empire often fell into true despair when they saw an impregnable wall growing before their eyes overnight. If the camp was planned to be long-term, all wooden structures were quickly replaced with stone ones without changing the original layout. This is how hundreds of cities appeared on the map of modern Europe, which originally began as ordinary legion camps. This quick start method allowed the empire to instantly establish itself in newly conquered territories. Construction was a tool of colonization that worked much more effectively than even the most sophisticated weapons. The Romans did not simply seize land, they immediately made it their own through standard architecture. The defense of the camp began with the digging of a moat, the depth and width of which were strictly regulated by statute. The earth from the moat was not thrown away, but piled up inside, forming a high protective rampart for the soldiers. Wooden stakes, which the soldiers always carried with them on campaigns, were installed on top of the rampart. This created an insurmountable barrier for enemy cavalry and infantry in a minimum amount of time. The entire perimeter was fortified so that there were no blind spots for firing. Engineers checked the strength of the embankment before giving the signal to rest. Inside the camp, space was allocated with mathematical precision to avoid congestion in case of an alarm. Each centuria knew its square and was responsible for its arrangement and cleanliness. Places for horses and pack animals were located away from residential areas for hygiene reasons. Drainage ditches were dug immediately after the tents were set up so that the camp would not turn into a swamp after rain. Such meticulousness allowed the army to remain healthy even in the harshest conditions. The Romans did not just build quickly, but with the highest quality even for a single night. It is remarkable that the materials for the palisade were often prepared in advance or obtained on site in record time. If there were no forests nearby, the soldiers used stones or turf to fortify their positions. Engineering ingenuity allowed them to adapt to any landscape without losing momentum. The army never felt unprotected, which boosted its morale. Every legionnaire knew that in the evening he would have a reliable roof and walls. This was the key to stability and success in great conquests. It is amazing how simple discipline can replace the most complex technology when approached correctly. Like this video if you are impressed by the organization of ancient warriors, and be sure to subscribe to the channel so you don't miss any new videos. How do you build a complex water supply system out of stone and sand without modern pumps? The construction of aqueducts required incredible precision in engineering calculations, as the slope of the gutter had to be only a few centimeters per kilometer of distance. If the builders made even the slightest mistake, the water would either stagnate in the channel or destroy the structure with its powerful pressure. The Romans built these giant bridges across deep valleys, using multi-tiered arches to maintain the stability of the entire system. This allowed clean mountain water to be supplied uninterruptedly to thermal baths and fountains many tens of kilometers from the source. The construction was carried out using huge wooden cranes and lifting mechanisms that were powered by human muscle power. Blocks weighing several tons were lifted to a considerable height with surprising ease thanks to a system of pulleys and counterweights. The stones were fitted together without the use of mortar in some parts of the arches, held together solely by their weight. Engineers created special tunnels in the Rocky Mountains so that the water would flow along the shortest and safest route. The speed at which such tunnels were dug was simply fantastic and inexplicable for that distant time. The entire construction process was divided into separate modules, which made it possible to build huge structures in record time. While one team was erecting massive arch supports, another was already preparing lead or ceramic pipes for the upper gutter. Aqueducts became a true symbol of civilization, bringing life to the most arid and inhospitable regions of the great empire. Access to water allowed cities to grow almost instantly, without fear of epidemics due to dirty sources. The Romans considered water to be the unconditional right of every citizen, and their engineering fully served this idea. The arches of aqueducts are still considered the global benchmark for engineering elegance and practical thinking of ancient masters. They not only performed their important utilitarian function, but also very effectively decorated the landscape of the empire. The ability of humans to completely subjugate natural resources through such structures sincerely amazed all contemporaries. It was a real intellectual battle with geography, which Roman engineers won time and time again. Aqueducts became an eternal monument to an era when the speed of construction radically changed the fate of entire nations. To speed up the work, the Romans used standard formwork for casting arches from concrete and stone. These forms could be quickly moved from one support to another without wasting time on making new ones. The craftsmen worked in sync, erecting several spans of the bridge at once from different sides of the valley. This technique reduced the project's implementation time several times over compared to traditional methods. The engineering plan was followed down to the smallest detail, ensuring a perfect fit between all parts of the bridge. The Romans created a system that worked like a well-oiled clockwork mechanism. The use of local building materials also contributed to the overall speed of water projects. Quarries were often opened in close proximity to the aqueduct route to minimize transportation costs. Heavy blocks were transported on special platforms that moved along temporary tracks. This ensured a continuous flow of stone to the construction site at any time of the year. The Romans did not wait for ideal conditions. They created them themselves for their work. Such persistence allowed them to complete grandiose construction projects in just a few years. The Romans understood the importance of resource quality for the health of the population of their growing cities. Each slab was fitted so as to prevent debris from entering the sealed channel. Such attention to detail was the key to the longevity of the entire water supply system. Aqueducts were the pride of the empire and clear evidence of its technological leadership. The scale of these structures still forces modern engineers to reconsider their views on the capabilities of ancient builders. We see huge bridges that were built without the use of modern surveying instruments and satellites. It was a triumph of pure intellect, mathematics, and impeccable organization of mass labor. The Romans did not just build quickly, they built with an understanding of the laws of nature and hydraulics. In the next chapter, you will learn how they coped with terrible weather conditions while constructing the most famous architectural monuments. What do you think was the most vulnerable part of the structure? The construction of the Flavian Amphitheater, which we all know as the Colosseum, took only 8 years from foundation to completion. For a structure of such colossal scale and complexity, this is an absolute world record for antiquity. Imagine a building that could hold 50,000 spectators with a complex system of underground passages and powerful elevators. The Romans actively used the block method, where individual parts of the building were assembled like pieces of a giant construction set. The stones were quarried in Tivoli and delivered along specially built wide roads directly to the city center. The Colosseum was built on the site of a huge drained artificial lake, which in itself was a complex engineering task. The engineers designed a unique system of awnings that protected spectators from the scorching sun and heavy rain. Huge masts and ropes were operated by experienced sailors from the fleet, as they required skills in working with marine rigging. This turned the amphitheater into a dynamic structure capable of instantly adapting to any human needs. Beneath the arena was a veritable multi-story labyrinth of cages and mechanisms for the sudden appearance of participants. The speed of setting up the scenery and changing scenes in the Colosseum was comparable to that of the best modern theaters in the world. Expensive marble was used for the exterior cladding, which was attached to the main walls with hidden metal pins. This allowed the huge building to be given a luxurious appearance in the shortest possible time. Thousands of slaves and free craftsmen worked here simultaneously, turning the construction site into a well-coordinated anthill. The organization of logistics on the site completely eliminated any downtime and delays in the delivery of necessary materials. The Colosseum became an eternal symbol of the triumph of Roman engineering and the unique organizational talent of the ancient rulers. The entire project was financed entirely by trophies from successful military campaigns to the east. The Romans understood that monumental construction was the best way to strengthen the authority of the government in the eyes of the people. The Colosseum was supposed to stand forever, reminding everyone of the boundless greatness of the great empire. And it brilliantly accomplished this task, safely surviving fires, earthquakes, and barbarian raids. The amphitheater's foundation extends to a depth of more than 12 meters and consists of a solid concrete ring. This provided the building with incredible stability on the soft soils of the former lake basin. The Romans poured concrete continuously to create a single monolithic mass without any weak spots. Huge amounts of soil were taken out of the city on special carts at night so as not to cause traffic jams. The city's logistics were subordinated to the needs of this great construction project throughout the 8 years. Each stage of the work was personally supervised by the emperor's top architects. The internal system of staircases and corridors was designed to evacuate 50,000 people in 15 minutes. Even modern sports complexes do not always achieve this level of safety and crowd control. Roman architects used mathematical models to calculate the flow of people in a confined space. Each staircase had a standard height and width for ease of movement. It was a triumph of ergonomics and practical calculation in the architecture of huge public spaces. The Colosseum was an entertainment machine built with the precision of a clockwork mechanism. Today, we look at these majestic ruins and try to understand how people without electricity built on such a large scale. The answer lies in the perfect combination of standardization, new materials, and an iron will to achieve the end result. Every stone here is in its place not by accident, but as part of a single global plan. The amphitheater was not just an arena, but the pinnacle of the architectural art of that amazing time. Roman engineers proved that the human mind is capable of great achievements with the right organization of labor. Are you ready for the shocking truth about how the Roman economy functioned on construction sites? I will reveal the most closely guarded secret of the success of Roman construction projects. It was their unprecedented and powerful logistics network. Every major construction project was supplied with resources through ports and rivers, where special barges transported thousands of tons of cargo. The Romans created the first standards in history for the sizes of bricks and building blocks, which made it possible to replace parts. This eliminated the need to individually fit each element, as was customary among other peoples. Construction became a process of rapid assembly of ready-made modules, which resulted in enormous savings in time and effort. The entire territory of the empire was covered by a network of state quarries where slaves and convicts prepared materials according to templates. A master builder in Britain knew for sure that a column sent from Egypt would fit perfectly into his foundation. It was the world's first global standardization system, operating flawlessly across 3 huge continents. The quality of materials was controlled by special officials who were always responsible for the strength of buildings. Corruption on state construction sites was severely punished, as the security of the great state directly depended on it. Engineers held an honorable position in Roman society and often had high military ranks and awards. They combined the skills of talented architects, surveyors, and managers, leading huge teams of people. Clear work schedules were used on construction sites, taking into account weather conditions and possible seasonal floods. The Romans never relied on luck. They calculated their every move, minimizing any possible risks. This allowed them to complete the most complex projects on time, which is a rarity even for modern companies. The workforce was organized into teams with a clear hierarchy, where each foreman was personally responsible for his section. Competition between teams was often used to significantly speed up construction on important projects. The best workers received cash rewards and bonuses, which effectively stimulated overall labor productivity. The Romans knew how to turn hard physical labor into a highly coordinated and maximally efficient process. Transporting heavy columns and obelisks required the creation of special ships with enormous carrying capacity. The Romans designed stone-carrying ships that could carry hundreds of tons of cargo in their deep holds. Upon arrival at the port, the cargo was transferred to river barges or multi-axle carts. Temporary roads made of wooden planks and rollers were used to move such heavy loads. Engineers calculated the pressure on the ground to avoid subsidence and accidents during transport. The entire route of the material from the quarry to the building was part of a single engineering project. High-speed horse-drawn mail was used to communicate between remote sites, covering hundreds of kilometers per day. This allowed architects in Rome to monitor the progress of work in the most distant provinces of the empire. Reports on material consumption and construction progress were sent regularly to special departments. Emperors often personally inspected important construction sites, emphasizing their national significance. Such involvement by the highest authorities guaranteed the absence of bureaucratic delays. Construction in Rome was a matter of honor and a manifestation of the nation's power. In the next chapter, you will learn how these technologies helped Rome survive in the harshest conditions of the north. In the next chapter, you will learn how they coped with this terrible weather when building bridges. Do you think it is possible to build a bridge across the Rhine in 10 days? The construction of bridges across the wide and fast-flowing northern rivers was the pinnacle of Roman military engineering. Julius Caesar, in his famous memoirs, described in detail the construction of a bridge across the Rhine in just 10 days. This was not just an engineering feat, but a powerful psychological demonstration of technological superiority over the enemy. The Romans used special pile-driving machines mounted on barges to drive the supports into the bottom at an angle. This allowed them to create surprisingly stable structures in conditions that had previously been considered completely impassable. Each support was securely reinforced with huge stones and protected from floating debris by special breakwaters. The upper structure of the bridge was assembled from pre-prepared beams, which were laid on the supports with precision. The bridges were built so quickly that the enemy was often cut off from their retreat routes ahead of time. The Roman army never stopped at water obstacles. It simply and technically removed them. This gave the legions a huge strategic advantage in any military campaign in the north of wild Europe. The scale of these structures led barbarian tribes to believe in the divine origin of Roman builders and their machines. The ability to move an army across a river in a matter of days changed the entire course of world history at that time. Roman bridges were not just crossings, but instruments of control over vast territories and rivers. Engineering was used here in the service of geopolitics, expanding the reach of imperial power. Every pile driven into the bottom of the Rhine was a nail in the coffin of the wild tribe's resistance. The use of floating platforms allowed work to be carried out in the middle of the river, even in strong and fast currents. Engineers developed systems of anchors and cables to hold the barges in a fixed position while the piles were being driven. This required perfect coordination between hundreds of people on the water and on the shore. The piles were made of hardwood, which was pre-burned to protect it from rotting. The Romans knew the secrets of wood preservation, which allowed structures to last for decades. The speed of work on the water was the result of long preliminary preparation on land. The wooden arches of Trajan's bridge had spans of more than 50 meters, which was a record for wooden structures. They were assembled from segments on shore and installed on stone supports using powerful winches. The whole process resembled modern bridge construction using prefabricated trusses and sections. Apollodorus of Damascus applied innovative load distribution methods that are still studied by engineers today. This bridge was a triumph of Roman genius, connecting the banks not only geographically but also culturally. The construction of such structures required a huge amount of wood, which led to the felling of entire forests in the surrounding area. However, the Romans established a system of resource replenishment and forestry for the needs of the fleet in construction projects. They understood the importance of the raw material base for maintaining their technological power over the centuries. Engineering was closely linked to ecology and the economics of natural resource use throughout the empire. The Roman bridge was the pinnacle of the integration of knowledge, resources, and an iron will to create. Rome was the first city in history to reach a population of 1 million, which required rapid construction. To accommodate such a large number of people, insulae were built, multi-story residential buildings that occupied entire neighborhoods. Roman engineers used concrete and brick to create frames that allowed them to build up to 7 stories. This was the world's first mass high-rise construction, solving the problem of acute land shortages in the center. The speed of construction of such neighborhoods was astonishing, as standard designs allowed houses to be mass-produced. Construction was carried out by private developers under the supervision of the authorities, who limited the height of buildings for safety reasons. The use of standard sizes for window and door openings allowed for the rapid production of the necessary carpentry. The Romans introduced the concept of neighborhood development, which is still successfully used in modern urban planning. The city did not grow chaotically, but according to clear plans, expanding its boundaries with new residential areas. This allowed the huge city of Rome to absorb thousands of new migrants annually without collapsing. The insulae featured ceramic tile floors and plastered walls, which were innovative for the time. This not only improved the appearance of the rooms, but also protected the structures from moisture and mold. Wealthy insula owners invested in facade decoration to attract more affluent tenants to the lower floors. The roofs of the houses were often flat or slightly sloped, using durable terracotta tiles. The Romans created a building materials industry that worked to meet the huge demand of the growing city. Each brick was a contribution to the stability of life in the capital. To ensure fire safety, narrow passages called ambitus were left between houses. Special night patrols called vigils worked in the city to maintain order and extinguish fires. Engineers developed methods of fire protection for wooden floors by coating them with special clay-based compounds. This reduced the risk of catastrophic fires in densely built-up areas where the poor lived. Roman law strictly regulated the obligations of homeowners to maintain their buildings in proper condition. The city was a complex organism, living by clear rules and standards. Mass production of bricks with factory stamps made it possible to track the origin of materials and control their quality. Each brick factory had its own unique style and recipe for firing clay in kilns. This created a competitive environment where the winner was the one who offered the best product at an affordable price. Roman emperors often subsidized the construction of cheap housing to maintain their popularity among the plebs. The housing industry was closely intertwined with the politics and economy of the great state. The insula became a symbol of Roman urbanization and social progress. Despite the simplicity of the materials, many walls of insulae have survived in Rome to this day, built into later buildings. This testifies to the high quality of the masonry and the durability of Roman bricks, which have not crumbled over the centuries. The builders of that time knew the secrets of durability that we are only beginning to rediscover today. The Romans created an environment in which millions of people could live, work, and thrive together. Their cities were monuments to human ingenuity and the pursuit of orderly comfort. Maritime trade was the backbone of the economy, so ports were built with state-of-the-art technology and speed. The port of Ostia, followed by the giant Claudius project, became recognized masterpieces of global hydraulic engineering at the time. The Romans used concrete that hardened underwater to create huge breakwaters and piers in the open sea. This made it possible to build harbors where there were originally no convenient natural bays for ships. Huge amounts of soil were removed by hand to create deep inner basins for the port and docks. Engineers created a system of canals connecting the ports to the Tiber River, which ensured direct delivery to Rome. Warehouses, shipyards, and administrative buildings were erected in parallel with the main complex hydraulic engineering works on the water. The port infrastructure was designed for a colossal annual turnover of grain, oil, wine, and marble. The use of powerful lifting cranes at the berths significantly accelerated the unloading of ships several times over. This made Roman maritime logistics the most efficient and fastest in the ancient world. The underwater construction technologies developed by the Romans had no worthy analogs in the world until the 19th century. They knew how to effectively isolate sections of the seabed using caissons to lay strong foundations. This required tremendous courage and a deep practical knowledge of the physics of water and pressure at depth. The speed and scale of this work transformed wild coastal landscapes into orderly and powerful industrial zones. Rome's maritime power stood firmly on the shoulders of its talented engineers and builders. To protect harbors from silting up, engineers designed systems of bypass channels and sluices that washed the bottom. This made it possible to maintain the necessary depth for large ships without constant manual dredging. The Romans understood the laws of tides and currents, using their energy for the needs of the empire's port economy. Each port had its own specialization. accepting ships with specific types of goods from all over the world. The infrastructure of the harbors included hotels, markets, and repair docks to keep the fleet in good working order. It was a global transportation system that functioned as a single organism. The port warehouses used innovative ventilation systems to protect grain from moisture and rot. The walls of the Horea were made double to ensure air circulation and prevent the products from coming into contact with dampness. The Romans knew that the preservation of cargo was as important as the speed of its delivery to the consumer. Huge reservoirs for olive oil were built of concrete lined with inert materials. This allowed strategic food reserves to be stored for long periods of time in case of crop failures or wars. The port was the guarantor of food security for the capital of the empire. Thousands of skilled carpenters, caulkers, and blacksmiths worked in the docks, capable of repairing a ship in a matter of days. The Romans introduced a system of standardization for ship parts, which sped up their maintenance in any port. This allowed the merchant fleet to spend more time at sea rather than waiting for repairs ashore. The efficiency of maritime transport was the key to low prices for goods in Rome itself. Port logistics was the invisible engine of prosperity for the great ancient state. The whole world was connected by sea routes leading to Ostia. Today, archaeologists continue to find sunken parts of Roman ports, amazed at the preservation of their concrete and masonry. Water could not destroy what was built with such expertise and attention to materials. The Romans left us an example of how to master the ocean, turning it into a road to progress. Their experience in building in a marine environment remains relevant to modern hydraulic engineers around the world. The sea gates of Rome were open to anyone who was willing to play by the rules of the empire. The engineering art of Rome left an indelible and profound mark on human history, completely shaping the face of modern Europe. Their methods of organizing mass labor, standardizing materials, and using concrete became the basis for all future progress. We still use many of their discoveries on a daily basis, often without even realizing their ancient origins. The Romans clearly demonstrated that human will and intellect are capable of successfully overcoming any natural obstacles. The speed of their construction was not just a record, but the only way for civilization to survive and prosper. Many secrets of their supreme craftsmanship were irretrievably lost after the fall of the empire, and it took humanity many centuries to recover. Today, the ruins of their magnificent buildings still serve as a source of inspiration for the world's best architects and engineers. The durability of Roman structures is a serious challenge to our modern culture of fast consumption and disposable items. They built for many millennia, investing deep meaning in every stone laid in the foundation. It was a unique art, inextricably linked with extreme practicality and efficiency. The Roman style of project management became the prototype for modern management in construction and industry. They introduced the concept of responsibility for results at every level of government task execution. This made it possible to create an infrastructure that united different peoples and cultures under one authority. Construction was an instrument of peace, creating conditions for trade and prosperity for all inhabitants of the empire. The Romans understood that a sturdy bridge or road was worth 10 victorious battles on the battlefield. Engineering was the true soul of a great state. We see the reflection of Roman arches and domes in the buildings of parliaments, courts, and universities around the globe. It is a visual code of power, stability, and law that the Romans have passed down to us through the centuries. Their understanding of proportion and aesthetics was combined with a strict demand for functionality in every element of a building. Roman brick and concrete became the literal building blocks of European civilization, upon which the modern world was built. We continue to learn from them the ability to see centuries ahead. Every modern project carries a piece of Roman experience. Modern archaeologists use laser scanning and satellite imagery to find roads and cities hidden underground. It is amazing how many objects are still waiting to be discovered, preserved intact under a layer of centuries-old dust. This testifies to the fact that the Romans covered every corner of their vast possessions with construction projects. They were a nation of builders who saw no limits to their creative and engineering genius. The search for new artifacts helps us better understand the lives and technologies of ordinary people of that time. Rome remains an eternal subject for study and admiration. The discipline of the legions on construction sites was as strict as in open combat with the enemy. This allowed dangerous work to be carried out without unnecessary losses and defects in building structures. The Romans valued the lives of their craftsmen and engineers, creating safe working conditions for them wherever possible. Training in the craft began at an early age and was passed on from master to apprentice within professional guilds. This ensured the continuity of knowledge and the constant improvement of the empire's construction technologies. Craftsmanship was a lifelong pursuit for thousands of builders. In conclusion, it is worth saying that the greatness of Rome lies not in its ruins, but in the creative impulse it gave to the world. We are the heirs of great craftsmen who were not afraid to challenge time and the elements. Their roads lead us into the future, and their bridges connect eras and generations. By studying the history of their constructions, we better understand ourselves and the limits of our capabilities. The Romans built the world in which we live today and laid the foundations for the world of tomorrow. Their legacy is immortal as long as the walls of their great creations stand. We conclude our fascinating journey into the world of the hidden and powerful engineering of ancient Rome. These monumental structures are not just pieces of stone and concrete, but evidence of human resilience and genius. They clearly show that great history is not only about battles, but also an endless series of creative challenges. Every engineer who built a road or aqueduct contributed to civilization's overall victory over chaos. The Romans proved that the most important resource of any army is its skilled personnel. Which Roman technology do you think was the most important for their success over the course of 1,000 years? Please write in the comments what other topics from the history of ancient technology you would like to see in the future. Your opinion is valuable to us and helps make this channel more interesting and insightful. Be sure to subscribe to our channel so you don't miss out on new exciting investigations into the great mysteries of the past.